With LEGO Mindstorms, you can build robots and use software to plan, test, and modify sequences of instructions from a variety of real-life robotic behaviors. You can gather and analyze data from sensors using data logging functionality such as Graph LEGO Mindstorms. By combining the power of LEGO Building System with the LEGO Mindstorms education technology, my team has designed different maps where the LEGO robot follows simple instructions of following tracks and turning around at 360 degrees where it senses or touches an object. The sensors that the LEGO robot uses to follow instructions are touch, light, and sonar. The light sensor will be used to follow our line, and the touch and sonar sensor is being used to reverse its direction when it connects or detects an object.
The light sensor is one of the more basic of the sensors. It detects light values from directly in front of the sensor, which is then used in the code to program the robot. For example, quite a simple code can be written, which will make the robot follow a dark or light line. When the sensor detects the darker or lighter shade of the line, it simply continues to follow the line in accordance, and when the sensor detects that the robot is moving away from the line, it changes direction to suit. This is a very simple code, and unless the line leads directly to the finishing point, is almost useless by itself. However, the robot can then be programmed so that it only reacts when the sensor detects a certain shade of light, or so that it may follow not the first line that it senses, but the second or third or fourth, and so on. Despite being a very simple sensor, the light sensor can be quite useful when used properly.
The next sensor is the sonar sensor, which uses sound waves to measure the distance from an object using sound reflection. It can sense an object up to 2.5 meters away as a value in centimeters of 0 to 250. This could be used in many ways, such as making the robot go towards an object, avoid it, or simply just measure the distance. In our code, it is used in conjunction with the touch sensor to make the robot spin around if it comes within 20 centimeters of a wall or object.
The third and final sensor that we are going to use today is the touch sensor. The touch sensor is the most basic sensor on Robot C. As you can see in the example, when the sensor is touched, the robot acts on the command and turns around. When the sensor is released, the robot knows that there is no longer an object in its way. Therefore, it continues with the commands that has been given and waits to be touched again.
When constructing the code for our robot, we had to start from scratch. The best way to start the programming is by making a flowchart. A flowchart is a simple diagram chart which shows how the robot is going to act. As you can see in our flowchart, it demonstrates step-by-step directions and decisions that the robot has to make in order to complete the track that we created, utilizing our 3 sensors. When the flowchart was completed, only then did we start making our code. Our task as a group was to take these 3 sensors and construct the appropriate coding using the Robot C software. To do so, we chose to create coding that would be able to test effectively on the Robot C software in the virtual world prior to testing it on the physical robot. As you can see, by doing this, we were able to test all of the sensors other than touch in the virtual world. The reason that we were not able to test the touch sensor was due to the sonar sensor, which was detecting the wall before the touch sensor was able to be used. Using our critical thinking as a team, however, we knew that in the physical test, we would be able to have an object low enough on one side of the course so that the sonar sensor would not detect anything before the touch sensor was engaged, and vice versa on the other side of the track. As you can see in the physical testing, the LEGO Mindstorms technology is extremely powerful and quite frankly very enjoyable to play around with. This video only touches on the tip of the iceberg, however, when it comes to this technology, and with enough practice and skill, almost anything can be constructed. This technology truly is the stepping stones to a career in large-scale robotics.